In the previous video, we moved the network from an unstable state to a stable state where there are no unstable triangles. So once that happens, it is possible to divide the nodes of the network into two groups. So that's what we are going to do here now. Let's create a function for that and let the function return two lists where the first list will contain the nodes of the first group and second list will contain the nodes of the second group. So let's create this function and let's call it C coalitions, and let's pass the graph here. So let's create this function here. Let's go up and we'll create this function. So so what do we have to do here? As I told you previously, the strategy that we are going to follow, as we explained here, let me write it here because this is the sixth step, the second last step. So we are going to choose a random node and we will add it to the first coalition. Now how do we choose a random node? Very simple. We'll first access the list of nodes. Nodes is equal to g dot nodes. So we got a list of nodes. Now what we have to do is we have to choose one node randomly out of it. The function that we can use for that is randint that we have previously used as well, or we can simply use the function random.choice which gives us one entry out of a given list. So we have this list as node, so we can use any of the functions. Let's use the function choice. R is the random node, so I will write random.choice. The choice should be out of this list nodes. So we got a random node here. Now since we have to return also and we have to keep track also, let's create two lists for each coalition. First coalition empty list, and similarly second coalition another empty list. So we're going to add nodes to this coalition. Now as I told you, we'll choose a random node and we will add it to the first coalition. So we'll write first coalition dot append r. Right now basically what we have to do is we have to run sort of a breadth first search on this node with an added condition that all the enemies of this node are not going to be a part of the BFS tree, right? So as I told you, we will look at the neighbors of this node, and some of these neighbors will be positive, some of these neighbors will be its friends, and some of its neighbors will be its enemies. So the neighbors which are its friends are going to be a part of the BFS tree. They will be explored further. However, the nodes which are its enemies are not going to be part of the BFS tree. They will not be explored. They will simply be put in the second coalition list. So that is the strategy. You can use any other strategy as well. So this is one simple method that works well. So as we do in BFS also, we keep a track of the nodes which have been processed already, the nodes which are yet to be processed. So we're going in the same fashion. So let's create for that purpose two lists, processed nodes initialized to empty, to be processed, say. So this list will keep track of all the nodes which are to be processed. Now since R is the node which has to be processed, we'll put R into it. Okay, now we have to keep running the loop of BFS until this to be processed list becomes empty, right? So we'll write for each in to be processed. Now in case the node is an enemy, what has to be done? It has to be added to the second coalition and it doesn't have to be processed. So we'll write elif, let me copy paste, if it's a negative sign, we will add it to second coalition if it is not already there. So we'll check if may I not in second coalition, we will add it there. So we'll write second coalition dot append nay I. That's one thing. Secondly, it doesn't have to be processed, so we are going to add it to be processed list. We'll write to be processed dot append nay I, right? Okay. Now by this time our node, that is each, which we started with, has been completely processed. So we will write here, we will write um, since it has been processed, we'll write processed nodes dot append each. So whatever we just processed, we'll add it to this list so that we are done. So this was the method to divide into first coalition and second coalition. Now this function has to return these two lists, so we'll make it return here, here. Okay, we'll write return first coalition, second coalition. Okay, the spelling is wrong, is it? Oh, I'm sorry. Second coalition. It's wrong everywhere. I'm sorry. Where else? Here. Okay. Okay. I think we're done. Summarize, we have added the friends of a given node to the first coalition and the enemies of the given node to the second coalition, and we are not processing the nodes which are going to go in the second coalition. Here, okay, I'm really sorry, we don't need to process the nodes which are added to the second coalition, so they will go to processed nodes here because they are not going to be processed again. Okay, so this is the function, and let's go back here and see if it works well. So we call this function C coalitions, and it's returning the two lists of nodes, first and second, and then we're printing these two lists. Let's see how it functions. So let's run this. This is the nodes, this is the networks with 5 countries. I'm closing it so that it can go ahead. Let me show you on some more countries so that we are able to nicely see the division into two groups. Let me increase this to 8 and then see. So these are the 8 countries. Let me close this. So it moved the triangle to stable state, and then it divided into two groups. As you can see, out of the 8 countries, 4 are in first group, and the rest 4 are in the second group. If we want to visualize as well, we can see. Let me add code of displaying the communities as well, the coalitions. Okay, this is how we displayed the graph previously. I'm just copying the code so that we can display it once again. Okay, so I'm executing it again. So this is the initial network. Let's take one example triangle. So Beerland, Gemra and Bercy, they have an unstable relation. See, there are two positive relationships. So basically, Zemra and Bercy are enemies to each other, but they have a common friend, which is Beerland. So let's see what happens to this. I'm closing it and it's doing its thing. And yes, this is what we had to see. Beerland, Zemra and Bercy, they all are friends now. So over time what happened, Zemra and Bercy, which were initially enemies, they become friends to each other. So you can check more examples as well. So overall this network is completely stable. In the next video, we are going to visualize these two groups that get formed.